Hi there, my name is J03. The purpose of my project was to identify a practical framework for a novel blockchain-based medical record management and verification system to increase record accessibility and transferability while preventing fraud via record verification. This project was inspired by a conversation I had with my family. At the time, my parents had both expressed concern that medical specialists they were seeing were asking them lots of complicated questions about their medical history. They were scared that they might not have provided correct information to the specialists. They wished that there was an app or online platform that they could use to access their real medical records at all times. After doing plenty of research, I found that blockchain technology could be used to address these issues. This project lays out the framework for the blockchain system I created, MediRecord. The MediRecord system has two main elements: a semi-permissioned blockchain backbone and a decentralized data string layer that can be controlled by the system's participants. These two elements work cooperatively to verify and authenticate medical records. A blockchain is a digital ledger of blocks that contain information designed for a specific use. Blockchains are unlike traditional databases because information cannot be deleted from the chain once it has been through a process called mining. Blockchains are also very secure and extremely resilient to data tampering. You may have also heard that blockchains have to be decentralized platforms, meaning that no one user controls access to the data on the blockchain or to the chain itself. This is a misconception. For example, MediRecord uses a quasi-permissioned blockchain structure. On the MediRecord blockchain, there are three different types of participants. There are Tier 1 participants, such as the provincial government and the Ontario College of Physicians, who are able to add new participants to the chain. There are Tier 2 participants, like the doctors and medical professionals, who are able to create new medical records and record a receipt of the transaction on the chain. And lastly, there are Tier 3 participants, who would be the citizens able to receive the records and check the record's authenticity. It is very important to note that the information on the records is never actually put on the chain for security reasons. Now onto a basic overview of the MediRecord system. Historically, the medical records have only been kept by the doctors and their practices who issue them. In the MediRecord system, digital copies of the records are given to the citizens, and each record can be verified using the MediRecord blockchain, even when the record is possessed by the patient. What this means is that a patient can keep a copy of their records at all times and use them to do things like fill prescriptions. They can use them when visiting specialists or when the patient is in the emergency room. The system will help prevent fraudulent documents from being created, as well as increase the information available to medical professionals about a given patient.
Now I'm going to use my proof of concept to further elaborate on how the MediRecord system works and how it can be used in practical use cases. So the proof of concept was built using Python and HTML and HTTP, a protocol to interface data between the two. So the first thing I'm going to do is go through a process called the initiation sequence. In this sequence, the Tier 1 node, in this case the Canadian government, or the Ontario government, would accept all the other nodes as participants, and they would register them credentials, a private key and a public key, based on their health card. These nodes would all accept the Tier 1 node as the dominant node, so they would get their permissions set through that process. So now I'm going to run the program on three different ports on my computer that each correlate to one of the participants. What I'm doing here is setting credentials for the three participants. This process would be done automatically, and the credentials would be sent to the participants over email or over physical mail. Now what I'm going to do is I'm going to have all the other nodes or participants accept the Tier 1 chain as the dominant chain. Now, all the other participants accept that this node running on port 5000 is a governing node, a Tier 1 node on the chain, and has those permissions. Now, these two nodes are Tier 2 nodes. They can add transactions, and this node can only receive transactions, this is the citizens, and they can verify and check the authenticity of documents. So now I'm going to go through a practical use case where a citizen or a patient goes to a doctor and receives a prescription. So the patient visits the doctor, and the doctor issues a certain prescription for a certain type of drug. The first thing the doctor is going to do is they're going to go to submit a document, and they have this text written out. So this text includes information. So the title, there's a patient name, there's the data about the prescription, and other data. And now this can be edited the way the patient wants, or the way the doctor wants, but right now it's just a very basic version. So they're going to submit that text. They're going to put in their own private key and public key. and they're going to put in the public key of the recipient, in this case the patient. Now, what just happened is that text that you saw, the prescription text, went through a process called digital hashing and then signing using the private key and public key of the document. Now, that hash is going to be posted onto the chain. So no information is really posted onto the blockchain about the medical information or about the patient. Just that hash that is a record of the text in the prescription. So if that text is altered, that hash will be different, and the patient and everyone will be able to see that medical record is not valid. So now this doctor is going to mine a new block so that transaction is added to a block, and all the other participants are going to resolve their chain so that they accept that new block. So after the doctor does that, they email that text file to the patient, or if the patient wants to be ultra secure, they can put it on a thumb drive, and then the patient is going to take that file right to the pharmacist, and the pharmacist is going to have a computer set up where they can check document authenticity. So here they're going to take that exact same text that was issued to the patient, they're going to enter the public key of the doctor, they're going to enter the patient's health card number, and then their own private and public key. If the pharmacist chose to fill the prescription as though it was only a one-time prescription, that would send a new transaction on the chain that invalidates that document from being used again. But in this case, I want to show what happens if you try and alter the document, so I will not fill this prescription. So the pharmacist enters all the correct information, and the blockchain returns that it's a valid document. So what happened is that this text was hashed again, and then the digital signature on the chain was de-signed using that hash and the public key of the doctor, and so therefore it returns whether or not the original message, in this case the record, has been changed or not. And so if we try and change the record, in this case I'm going to say the patient wants to get drugs fraudulently, or prescription drugs fraudulently. So they're going to say I want 100 milligrams or I was prescribed 100 milligrams. If they go to submit that and check it for authenticity, it'll return as not valid, and the pharmacist will know not to fill that prescription. But if that prescription is kept the same, it'll go back to being valid. So now I hope you can see how this could be extremely impactful in not only the pharmaceutical industry, but also in the medical industry as a whole, because this same technology could be used to verify medical documents in any facet of sort of medicine. So if you're visiting a specialist, if you're going to the EMR, your entire medical record history can be verified and used to treat you and treat symptoms and assign more accurate diagnosis and treatments.
Thank you very much for listening to my presentation.